Hi everyone, welcome to this last video on planes. This is the video on vector planes number 3. So we're going to look at 3 things here in this video. We're going to look at how to work out the distance from a point to a plane, the shortest distance, that's the first one. We're going to look at how you work out the angle between two planes and also the line of intersection of two planes. 3 things to wrap it all up. So first one, the foot of perpendicular from a point to a plane. So you can see from the diagram that the quickest way of getting from this point to the plane is obviously going directly to the plane. Okay, so that angle between PF and the plane is going to be, you guessed it, 90 degrees. So they're going to be perpendicular. So let me do the working for this particular example. So how are we going to do it? We're going to find the equation of P to F, and we're going to solve simultaneously to find the intersection of the line and the plane, and we did that in the last video. That will give us the point F. Then we can use Pythagoras in 3 dimensions to find the length from P to F. Okay, so let's do it. Find the position vector of F, the foot of the perpendicular from that point to the plane pi with that equation there. Find the perpendicular distance of the point P to the plane. Okay. Let me draw a little diagram, which kind of helps, even though it's only 2-dimensional. So we've got our point up here, and this point here is P. Let's imagine we've got a line going straight down there to the plane, and that line is going to be perpendicular to the plane, and we'll call this point down here at the bottom F. Okay, what is the equation of PF? Well, it's a line, so we know it's kind of going to be in this form. Point on the line and then move in the direction of the line. So what's a point on the line? That's easy, that's P. 6, 5 minus 4. What is the direction the line is going in? Well, the direction the line is going in is the same as the normal to the plane. And we know that we can get that by looking at the equation of the plane. And all we have to do is look at the numbers in front of the x, y, and z coordinates in this Cartesian equation. So the normal to the plane here is 2, 1, minus 2. Okay, and that is the direction the line is going in. 2, 1, minus 2. Cool. So that's the equation of the line. Now we solve simultaneously, and we did that before. I showed you that in the last video, how you would then find the intersection between this line and this plane. So I'm going to skip a few steps here, but let me set it up. 2x plus y minus 2z plus 11 equals 0. So the x coordinate here is, let me highlight this, 6 plus 2 lots of lambda. So we've got 2, 6 plus 2 lambda plus y. Well, the y coordinate is 5 plus lambda. Minus 2 times z. The z coordinate is negative 4, negative 2 lambda. I'm sure you can see where I'm getting those from. Cool. That gives you an equation in lambda to solve. And I'm going to skip out a few steps here and tell you that you get lambda equals negative 4. Alright, so then we can work out now what the point F is. Just add an extra page in here. Okay, so now with lambda equaling 4, we know we can get this. 6, 5 minus 4 plus negative 4 times 2, 1 minus 2. So the position vector of F is negative 2, 1, 4. You can check my working, make sure that's right. So therefore the coordinates of F is negative 2, 1, 4. So once we've found F, it's a real simple matter to find the distance from P to F. We just use Pythagoras in 3 dimensions. So the length of P to F would look like this imposing looking thing. We'll start with F, so we'll say I'll start with P. So 6 minus negative 2 squared plus 5 minus 1 squared plus coordinates of p, last one is negative 4. Negative 4 minus 4 squared. Once again, let me go, that is the square root of 144. Wasn't I quick? That is 12. There's how you find the closest distance between a point and a plane. Let me show you what that looks like now. If we have a look at the picture of this, here is that plane that we were talking about. It's a little bit difficult to see. We've got this line going through here, and that point that I've identified is 6, 5, negative 4. So next one is really simple. If we want to find the angle between two planes, we find the angle between their normal vectors. Let's zoom in on this and see if this makes sense. Okay, so I've got the normals to these two planes. If I use the method that we use to find the angle between two lines, I just find the angle between those two normal vectors. That will give me either this angle here, or it could spit out this angle here, depending on which direction you use for this vector. Okay, so you might use the vector going in that direction and this one going in this direction, and it may give you an obtuse angle. So either way, you can see that the relationship between those two angles is that they add to 180 degrees. So if the question says what's the acute angle between the planes, you do the calculation using the basic formula. Let me write that formula down again. So it will be A dot B equals the length of A times the length of B times cos of theta. So if you do get an obtuse angle when you use that formula and ask for the acute angle, you just say 180 minus that answer, and you've got it. Easy. Last one. If we've got two planes, what I now want to find is what is the equation of this line that forms the intersection of the two planes. This is a little bit trickier. The way we're going to do this is recognize that to get the equation of a line, we need two things. We need a point on the line, and we need the vector in the direction of the line. Okay, firstly, the vector in the direction of the line. This is the trickiest bit. If you look at the normals to the planes, and you do the vector product, and this is easier to demonstrate in 3 dimensions, but if you think about it, if you do the vector product of those two normal vectors, what vector do you get? Correct, a vector in the direction of the line. You need to do this with a few books and a ruler to really convince yourself, but that's it. The vector product here gives you the vector of that direction. Now we just need to pick one point on the line, and that's pretty easy to do since there's actually infinitely many points we could pick. So let's go through it with this question right here. Find the line of intersection of those two planes. Okay, so what are the normal vectors that we're talking about here? We can see, because they're given in Cartesian form, it's pretty easy. The normal vectors are 4, 2, 8 for the first one, and the normal vector for the second plane is 5, 4, 8. Okay, so we want to do the vector product or cross product, which, as we know, gives us a vector. Okay, just pause quickly and do that and make sure you can get the right answer. Okay, if you did it right, you should have got negative 16, negative 8, and 6. And as a few of you asked me, yes, you can take out a common factor here. So you could take out a common factor of 2 and call this negative 8, negative 4, 3. That would also be a vector that's normal to the planes and therefore in the direction of the line. So you can use either ones, it doesn't matter. Now we just need 1 point on both planes. So we've got 4x plus 2y plus 8z equals 4, and we've got 5x plus 4y plus 8z equals 1. Easiest thing to do is just eliminate one variable. So solve simultaneously. The obvious one here is 8z. If we subtract the equations, so I'm going to say the second equation minus the first equation, we get x plus 2y, 8z minus 8z is 0, and 1 minus 4 is negative 3. X plus 2y equals negative 3. Now you just need to find any x and y values that satisfy that equation. So we're going to start guessing here. If I say x is equal to negative 3, y is equal to 0, let's take that one. That's the easiest one, I think. I could have chosen, x equals negative 6 and then found the value of y after that, but I'm picking, all I need is 1 point. So I've got x equals 3, y equals negative 0. What's the z value that corresponds to that? Well, all I'm going to do is substitute that into either one of these two equations to find my z value. And if you quickly do that, you will see, if I put x equals negative 3 in the top one, I get negative 12 plus 2 times 0, so just negative 12 plus 8z equals 4, which gives me z equals 2. There we go. I've got a point on the line, and that is all I need to get the answer. The equation of the line is negative 3, 0, 2, a point on the line, plus lambda, negative 8, negative 4, 3. And yes, note that this answer is definitely not unique. There's many ways that we could write that line, but that is one correct answer, and that's the way that you do that one.